I'm Tim Ventura from AmericanAntiGravity.com, and I'm talking today about cold fusion with Stephen Krivit, the senior editor of the New Energy Times and author of a new book on the subject entitled The Rebirth of Cold Fusion, which is going on sale November 8th. Well, Stephen, I guess I should start out by thanking you for speaking with us today, and then also asking you a little bit about your background. What can you tell us about, your kind of goals and interests, and what got you into cold fusion research in the first place?
Thank you, Tim. It's a pleasure to speak with you today. Well, I'm actually a computer geek. As far as my background, I became curious about cold fusion initially in 1989. Didn't hear anything about it for 10 years. And then my curiosity got reawakened in 1999, and I started searching around the web for information about it. I found two things. One, the information that I was able to get through my web searches was either too obscure or too technical, and I really wasn't able to find anything useful about it. The second thing I found was that there was a huge polarity in the differing points of view on the subject, as there still is today. I found references to cold fusion that said that it was going to be the answer to mankind's energy problems. I found references that indicated that it was a hoax and it was pseudoscience. So I said, this is really strange. So I pursued a course of investigation on my own, and I traveled around, visited a few laboratories, interviewed researchers firsthand. And the New Energy Times website was the evolution of what I found, and it was my way of sharing with the public what I found, and at each step along the way, I put whatever I found on the website, and that's how my interest developed in the subject.
Well, cold fusion is certainly an innovative new field, and it's had more than its share of criticism. A lot of it unfairly. It kind of started getting criticism right from day one. And so I guess one of the things I should ask is, what's the bottom line on cold fusion? Is it for real, or is it just something that kind of defies explanation, I guess?
Well, there's several different answers to that, and there's actually several different questions involved in that apparently simple question you asked. In terms of the question, is cold fusion real, it's going to depend to a certain extent on one's point of view. But on another perspective, if you ask the question, is it genuine science? Is it backed by empirical demonstrations that have been reproduced through a variety of methods by scientists who are skilled in their particular area of expertise in many different laboratories around the world? Absolutely. It stacks up against the common expectations of what a true science is. If you ask the question, well, have the results been ever published in peer-reviewed journals? Yes, they have as well, although very infrequently lately, but they have in quite a few peer-reviewed journals. If you ask the question, is cold fusion real in terms of solving the world's energy problems? We don't know that yet. And that's the big question. Certainly people who are enthusiastic about it hope so, but that cannot be known yet.
So we might have to wait a little while for a device like, say, out of the movie The Saint, where he has the cold fusion generator that blows up the light bulb and generates so much energy it lights up Moscow. That was a particular favorite example from the movies for me. But
oh goodness, yes, that's a very popular movie. I have to admit seeing that on more than one occasion. There's actually a somewhat of a common misconception that movie has conveyed on the subject, because people are expecting to see something that dramatic to convince them. At least that's what happened in the movie. The crowd goes, "Oh wow, look at the smoke, look at the light, look at the flames. It's real." But you can't determine that cold fusion is real because from a visual observation. Cold fusion has been determined to be real by scientists who know what they're doing through very careful instrumentation and very skilled use of that instrumentation. And when cold fusion becomes, if it becomes commercially viable, we may never see something that dramatic. Of course, there are plasma displays that occur in various types of experiments that do show dramatic light and smoke and heat, but those don't mean anything. Those could be effects of a profound energy source, or they could just be effects of that particular experiment that just happens to be converting one form of energy into light, or it doesn't actually mean anything.
Sure, sure. Well, there are a couple of things that are being generated in the lab, and one of those, apparently, at least from my reading, has been lots of excess heat in lots of experiments. And the other, which is a little bit more of a smoking gun from what I've read, are nucleotides, and these are almost fusion byproducts suspended in solute in the water that seem to indicate that there are fusion reactions happening. You know, they weren't there when they started the experiment, but they are at the end.
Well, exactly. And again, there's a very significant point of view on the evidence to support the nuclear reaction, the claimed nuclear reaction. You know, if you are a chemist and you are familiar with chemistry, and you know how much heat is supposed to come out of an electrolytic cell, and you see what goes on in a cold fusion cell, you'll say, something's wrong here. You're getting 1,000, 1,000,000 times more heat out of an electrolytic cell than you should be getting. And so the chemists see this very clearly when they look at the excess heat, that it's not chemistry as we know it, or as they know it. And they initially thought that, well, it could be nuclear, could be something else. But subsequently, when they found that helium-4 seems to be the dominant byproduct through these reactions, and that the amount of helium-4 that is measured from these reactions seems to correlate very closely with the amount of heat that comes off, it matched the understanding of what happens when you fuse two deuterons, two deuterium atoms together. The mathematical equivalent of that indicates that you get a certain amount of excess energy and heat, and that's what they found. Now, if you're a physicist, well, I'm generalizing here, but most physicists don't have experience in measuring heat. It's not something that's part of nuclear physics, but they have experience in measuring tritium, neutrons, and other nuclear byproducts. Tritium was the first nuclear product that was seen initially, and in fact, it was actually seen within several weeks of the initial announcement of the cold fusion discovery on March 23rd, 1989. Of course, there were many people who failed to see tritium, and there were many debates about whether it was real, but there's plenty of evidence that shows it showed up in, it must be dozens of reports from various laboratories all around the world. So tritium has been one of the, and it's not it's not a major product of cold fusion. It only shows up rarely in small amounts. However, you can't get tritium from chemistry. You can't get tritium in large concentrations, much higher than background levels. You just can't get that in any other way than a nuclear reaction.
Certainly. Now, one of the things that I saw a few weeks ago in the store was an issue of Popular Mechanics, I believe. And it had a story on the cover. I read a little bit of it, and the claim they were making was that cold fusion could be used to produce a nuclear device, I guess, a weapon of mass destruction. And I kind of had a double take on this. I guess, from one perspective, it's needless sensationalism. I've never seen the possibility of that, at least in the short term. But on the other side, it does tend to reinforce the idea that this is a real technology that can generate useful amounts of power. After all, a giant explosion releases a giant amount of energy. And I'd like to ask what your take on this might be in the media. Is this a possibility? Is this something that a terrorist organization could use? And if so, you've mentioned a lot of nuclear byproducts. How difficult would that be to build?
Well, this was a very sensationalistic cover story. I saw it. Actually, I was interviewed partially for the story before it came out by Jim Wilson. And interestingly, before Jim Wilson started working on this story before Gene Mallove was murdered, and it was for some reason he shifted gears significantly. He was originally planning on exposing what happened at MIT, which was basically a fraud in their cold fusion experiment. And once Gene was murdered, I guess the story shifted to more of this conspiracy type and weapons concern. I know that tritium, of course, it's unequivocal that it does show up in cold fusion experiments. Now, whether tritium can, and I've also spoken with several scientists, one of them at Los Alamos National Laboratory, a gentleman who happens to know quite a bit about tritium, quite a bit about nuclear weapons. And, that's the birthplace of a lot of nuclear research. He hasn't been able to produce tritium reliably from cold fusion experiments for several years. The best they got was, I think, a 20% reproducibility, but they still couldn't figure out what made it work. And it really doesn't show at the moment, from what I can tell and from what's been disclosed to me, that it's a reliable way of making tritium. But this is very early in this field of science, and do I think it could inevitably be scaled up to produce larger amounts of tritium? Sure, yeah, that's possible, and that would fuel or refuel conventional nuclear weapons. What the Popular Mechanics article was also alluding to, which, as far as almost everybody in the scientific community says about the article, it was really speculative and quite baseless, and quite a few people really don't understand what Gene Mallove was being quoted there. Even his close colleague Mitch Schwartz doesn't understand the quote that was attributed to Gene and questioned the accuracy of it. But the speculation that you'll get enriched plutonium, enriched uranium from cold fusion, it seems really far-fetched now. But I'm not saying that might never be possible.
Well, it sounds like the amount of development that would have to go into it would outweigh kind of the benefits, and I
don't know. I think if there's any truth to it, it's not going to be known for many, many decades. It's much closer to science fiction than any other fact of cold fusion that I know of.
Well, speaking of Eugene Mallove, one of the things that I'd like to touch on, because we had a recent tragedy earlier this year, Eugene Mallove was unfortunately taken before his time, and that seems to have affected the cold fusion community, as he was a catalyst for a lot of breakthroughs and just sharing new information that different researchers have been doing with each other. How do you think that'll affect the community? How has that affected you, losing such an eminent physicist?
It was rough. Gene Mallove was not only my friend but my mentor in this. He, for many people, he was the spearhead to bring this information out to the world over the last 15 years. Without it's quite clear that without Gene's efforts through his book, I think it was 1991, through his magazine, which started after that, I would say that many of the cold fusion supporters and researchers probably would have either given up or not have had the opportunity to share their information. The magazine that he produced was unique. There was nothing else like it, and I suspect I don't know how it's going to continue. They're not having an easy time, I know, trying to figure out where to go next, but I don't see how that magazine is going to be replaced in any easy manner at all.
Well, do you think that his loss will have larger repercussions also on the cold fusion research? Do you think it slows down maybe the development and release of some of the next generation power supplies they've been working towards?
Well, that's an interesting question. I actually started becoming very highly involved in communicating the information about cold fusion to the public within the last year. I've been researching it for 4 years, but I've been very active in it within the last year. Gene actually went through a very interesting phase in the last few years. He actually started phasing away from his interest in cold fusion. I don't know if you know that or not, but his interest started getting into a lot more esoteric areas. And he actually, at the ICCF 10, he had certain viewpoints about cold fusion, but it was actually starting to be somewhat different than a lot of the other cold fusion researchers. Now, Gene didn't do cold fusion research much himself. He was more of an editor or writer. Gene's going to be missed most for his... There's so many things about Gene that are going to be irreplaceable. He was an incredibly intelligent person, incredibly well-spoken. He knew his science cold. He had a very thorough background in science journalism. And it's not going to be easy for the cold fusion community to have anyone replace what Gene did in terms of being an aggressive spokesperson who is able and willing to confront the scientific orthodoxy on cold fusion or the other areas that Gene was interested in. But there are several people, myself, and a few other journalists around the world who have taken up an interest in continuing to communicate these subjects to the world, and it's probably going to take a half a dozen people or so to fill in the gap that is going to be missing now from Gene's absence.
That's definitely true. Now, your website is New Energy Times, and that's just one long word, right? www.newenergytimes.com.
That's it.
Yeah, and hopefully, I know that Infinite Energy, and their URL is infinite-energy.com. I know that they're still in business, and Christy is making a Herculean effort to pick up some of the slack from, just the disturbance that's happened. One of the things that I talked to Gene about, I talked to him several times over a 2-year period regarding Lifter's new energy technology and occasionally about cold fusion. And one of the things that we both shared, I guess, a view of was that eventually, sooner or later, cold fusion could be used to power some of the devices that I've experimented with, as well as the devices that others are working with. A lot of people hold the connection that anti-gravity field effect propulsion devices may tap into the ZPE and power themselves, And I've never been quite as confident. I'd always like to have that backup strategy of, a high energy output source that you could hook up to the device and power it. That's especially pertinent in space, where you can't use a turbine to generate electricity or anything along those lines. So that was something that we had shared in common. And I guess in another sense, he had been pushing me towards an aetherometry website that was run by Korea and Korea, and they were also doing work along similar lines, and I believe also hoping to use someday cold fusion to power some of that. Well, I have a document here that you've sent me, and it has just kind of some statistics that I'd like to read off. Um, Basically, what you're saying is that there are 400 researchers around involved with a worldwide effort researching cold fusion. And on average, the excess heat effect is 83%. That's what they're reproducing. They're also, on average, producing an excess power of 1 watt with peaks up to 80 watts. Also, it appears that the reproducibility goes up to 100% within known batches of palladium. So it sounds like they're making real progress here. Is there anything you have any thoughts on with regard to that?
Oh, I think they are making incredible progress. 5 years ago, the survey question I asked the scientists last year at the conference were included. What was your reproducibility 5 years ago? What was it within the last year? And on average, they said it was around, I'd say off the top of my head, I think it was about 40% 5 years ago. And the palladium is a very interesting situation because once they have several of them, one, Mel Miles, who worked with the Navy, Ed Storms, who's retired from Los Alamos, Antonello Danino, who works for basically the equivalent of the DOE over in Italy. Maybe there's a few others. They told me that once they found palladium that shows the excess heat effect, that exhibits the cold fusion effect, if they use palladium from that same batch, 100% of the time, they'll get it to turn on. So that really drives home the point that it's not, cold fusion is not that unknown to the scientists at this point. It's the materials issue, which is one of the biggest roadblocks right now. It's the question of what is going on with this material, and it's likely to have something related to the atomic structure of each individual piece of palladium, something down at a nanometer level that makes one piece of palladium different than another, and impurities are likely to have a large effect to making it work or not.
Well, I wonder if cold fusion, in a way, at least in a very general sense, is tied to some of the other new science technologies out there. One of them was the work of Dr. Paul Brown, and he was working with stimulated decay fission batteries. And he'd found that by putting a high voltage static charge on a nuclear material, like americium, that would be a poor example because it also emits neutrons, or some of the other electron emitters, he was actually able to generate and sustain a fair amount of current from that. Another example is the plasma volt that Michael McDonough has been experimenting with, and some of the more radical approaches to fusion generation. But I think one of the common threads here might be that this technology, that the cold fusion technology that's being researched all over the world at the moment, in fact, it looks like it's being done everywhere except the United States for the most part, has the potential to rewrite the physics of nuclear interactions.
Well, it is being performed in the United States, but mostly in private laboratories. SRA International is one of the most prominent laboratories that work has been performed in. I don't know if they have funding now, but they have had funding in the past from some quiet funding from DARPA. They've had, years ago, some significant funding from the Electric Power Research Institute. And I want to touch on a point that you alluded to, that cold fusion may have some relationship to some of the other areas of science and research that are being developed. And I would have to say that that's probably correct. They're probably all related somehow, although I have no expertise in those other areas, Dr. Paul Brown's work, and I really can't speak for them, but I would just venture a guess that inevitably we may learn that they are related. And clearly, cold fusion represents new understandings of physics. I can speak more about that if you'd like.
Well, I can't tell you exactly what the relationship is either, but one of the things that I have noticed just from reading some of Brown's notes and from some of the other experiments out there, even with the lifters, people have claimed that by putting a nuclear emitter substance, again, americium from a smoke detector battery, the claim has been that this makes the lifter work a little bit better because it breaks down and releases ions. Now, I don't know how true any of this is, but it seems like the common element there might be this low-energy nuclear reaction. Something that isn't explosive in nature, but just delivers energy. Really what we're looking for in the first place from these things. And,
well, that's... oh, I'm sorry, go ahead.
Well, I'm just wondering if maybe there's a loophole in physics there, and these all fall in that category. Physics tends to claim that you have to have lots of energy in a very concentrated form to be able to make these reactions occur. And if these devices work, as it looks like they may, we may have found the perfect loophole for new energy.
Well, you said a lot there. You've introduced a new term here, and let's just make sure people caught it. You said low-energy nuclear reactions, and that is a term that is being used a lot to refer to cold fusion research, perhaps as well as other research. They use the term low-energy nuclear reactions because there are reactions that are occurring with the palladium and deuterium, or sometimes palladium and hydrogen, or sometimes nickel and titanium hydrogen combinations that are not fusion at all, have nothing to do with fusion, but they show nuclear reactions. They show heat. On a large scale, they show transmutations of heavy elements. And this does indeed open up a whole new world. And there's something you've been mentioning that I wanted to respond to about a new world in physics opening up. And I think cold fusion is starting to show that as a window to what we may see in the future. I can give you an example that one of the reasons why cold fusion is so hard to accept and so hard to believe by some people is that nuclear fusion has been understood for 70 years now. The theories came out in the 30s and 40s. And the work in nuclear fusion and hot fusion has basically surrounded this set of theories that evolved 70 years ago. And some of the leading physicists, theoretical physicists, who have been looking into cold fusion have wondered, well, if cold fusion is possible, how can it be possible when one takes into account what is known and understood with conventional fusion theory? And what happened is they went back to the original theories back in the 30s and 40s, and they examined them, and they looked into how they were first derived, and they found that they were derived based on current experience at the time of nuclear fusion, which did not take into account the possible reactions of a nuclear effect within the lattice, within the surface of a metal, as occurs in cold fusion. And they found that if you take that factor into account, and you also add a few small, subtle changes to the understanding of the theory, that new theories now do allow for an understanding of how cold fusion is theoretically possible, as well as shed light on existing hot fusion theory. So how's that?
Well, I think that in combination with some of the work of Eugene and yourself and others who were helping to publicize this research is finally starting to swing the public view. The Popular Mechanics article was kind of a dystopic view of it, but the DOE has recently picked up, renewed interest in this. And one of the real parts of the tragedy with Eugene was that he passed shortly after the DOE officially decided to reinvestigate this technology. Do you have any thoughts on that? Is it kind of a bright day for cold fusion still to come, or?
Well, back on Gene's perspective, it's quite sad. However, he was around long enough to know that they had picked it up again and were starting to take it seriously. And if you look at some of his last writings on the subject, you can see just an amazing sense of hope and satisfaction in some of his expressions. It's really sweet to see.
Yeah. It was a small consolation too.
He did start to see it. We're at a very interesting time in history. In fact, we could be days away from a historic announcement, or who knows, there could be nothing that comes out. But the Department of Energy has told the cold fusion community, well, they've told them several things. Now, this review that has been going on for the last 6 months, the first time since 1989 that the Department of Energy has officially taken another look at cold fusion, and this itself is historical. The results of this review were initially promised to come out sometime in September, and they were delayed apparently due to some of the reviewers falling behind in their schedule to submit their written summaries. The latest word we have from the Department of Energy is that they are hopeful. I don't know if they use the word committed or hopeful, but I'll just say that they're hopeful to have the results out by the end of this month, which is 11 days from now. So if they do hold to their expectations, we are either going to see a profound announcement from the Department of Energy on cold fusion. Perhaps what seems logical to me is that they're going to say, yes, there is real science behind this research, and we should probably look further into it. It's inconceivable to me that they could come out and say anything besides that. They looked at 137 papers, or data from 137 papers that showed evidence of supported cold fusion. How 20 or so reviewers who are supposedly impartial from government laboratories and various universities through the U.S. can conclude anything otherwise. It's inconceivable to me, however. This is politics, so something could happen. Now, on the other hand, they could come out with no announcement at all. We may never hear of anything. So those in the cold fusion community are rather on pins and needles, waiting to hear whether there's going to be a profound announcement or not as we speak.
Well, and that's a good note to close on for today, because we're almost out of time. But when the November announcement comes out, even if it is pushed back a little while, that's something that you'll have up on the New Energy Times website. And that's newenergytimes.com. And Stephen, thanks again for your time. Is there anything you'd like to say in close?
Oh, it's a pleasure speaking with you, Tim, and I look forward to speaking with you further as things develop.
Absolutely. The pleasure has been all mine. It's great to finally get an update on cold fusion and see that, things are still moving forward. And even if there are minor setbacks along the way, this technology looks more and more promising every day.